Hello everyone. Today we are gonna solve some Excel problems related to risks and return. In the very first problem, we have annual price data along with corresponding dividend data from the year 2016 to 2021 for two different companies, Goodman and Landry. And then we also have the price information data for the market index. Now, in the very first problem, we are going to calculate the holding period return for both of the companies and the market from the year 2017 to 2021. Now, the formula for holding period return is ending value plus dividend, if any, minus beginning value divided by beginning value. So we're going to apply this formula here to calculate holding period return for both of the companies and the market. So here for Goodman, the ending value in 2021 is 25.88. This is the last value we have in 2021. Then plus the corresponding dividend in this particular year is $1.73. Now, for this particular year, we started with the ending value of the 2020. So that is the beginning value. So minus beginning value divided by beginning value. All right. So this is the holding period return for Goodman Company in the year 2021. So we're going to apply the same formula to calculate holding period return for Landry. Ending value plus dividend minus beginning value divided by beginning value. Next, return for the market. For market, you can see the price already includes dividend, so we don't need to adjust dividends separately, right? So here, ending value minus beginning value divided by beginning value. We're gonna copy the same formula in all the other years. Next, we are going to calculate average return. So we're going to apply the average formula. Now, the average return for Goodman Company is 29.4%. Then average return for Landry is 2.7%, whereas the average return for the market is 20.6%. So in this case, Goodman Company outperformed the market because the average return for Goodman is greater than the average return of the market. On the other hand, Landry underperformed the market. Why? The average return of Landry is less than the average market return. In the next step, we are going to calculate volatility of the holding period returns for a particular company. And then one of the measures of the return volatility is standard deviation. The formula for standard deviation is STDEV, and then choose the return series for which you want to calculate the standard deviation. So you can see here, Goodman Company is the most volatile stock here, and then the volatility of Goodman is even more than the volatility of the market. So it confirms what we say in finance: the higher the risk, the higher should be the return. So Goodman has more volatility, or in other words, more risk, then the return should also be higher. And that is what we get here. On the other hand, Landry has the lowest volatility among all the three you can see here, and therefore Landry also generate the lowest return among all the three um, um, companies and market we have available here. Next, we are gonna draw a regression line for both of the companies on the market index. So in this case, the return of the company should be Y value, and then return of the market should be the X value. So in the XY panel, you should put stock return on the Y axis and market return on the X axis. Then we're going to draw a regression line, and the slope of the regression line will be your beta. Right. So let us draw the regression line. Okay. First, let us choose just market and Goodman company. Then go to the insert menu. From there, choose the scatter plot. So now we got the scatter plot for Goodman and then the market. And then here, market return is in your y-axis, and then Goodman return is on your x-axis. Now we are gonna draw regression line. So first, choose any point in this scatter plot, and then hit the right button of your mouse. Then from there, choose add trend line. So trend line is added. So this is the regression line, best fitted linear regression line. And then from the format trend line function, you can see here on the right side of our window, choose display equation on chart. So here you can see the slope of this particular equation is 1.5377, and that slope should be the measure of beta. So the beta of Goodman is 1.53. Okay, now let us draw the scatter plot for Landry too. Okay, so we are going to just extend it to Landry. Now you can see scatter plot for Landry, and choose any point for Landry, and then again using the right button of your mouse, choose add trend line, and then again from the format trend line drop down menu, choose display equation on the chart. So here the slope of this particular equation is negative 0.56. So the beta for Landry should be negative 0.56. Right. So now we have our chart here. Next, let us now use formula to calculate beta of Goodman and Landry. And the formula is slope. And then, as you know, Y is what? Stock return. So choose stock return. And X is what? Market. Now beta of Goodman is how much? 1.54, as you can see here. From the regression equation, you also get the same value. Now let us calculate beta for Landry slope. Y value should be the return of Landry, and then X value should be the return of the market. So here again, the beta of Landry is negative 0.56, and that is the exact number we got from the regression equation 2. Now, let us use capital asset pricing model formula to calculate required return for both Goodman and Landry. All right. So now, according to the information, the risk-free rate is how much? 6.04%. Market risk premium is how much? 5%. Then beta for Goodman is how much? 1.54. Then the required return according to CAPM is risk-free rate plus market risk premium times beta. So the required return for Goodman is 13.73%. Now let us calculate required return for Landry. Again, let us plug in the value for risk-free rate, market risk premium, then times beta, negative 0.56. Then let us now calculate required return. So you can see here risk-free rate plus market risk premium times beta. All right. Now let us calculate portfolio beta. So here our assumption is we are going to invest 50% of our portfolio in Goodman stock, whereas we're going to invest 50% of our portfolio value in Landry stock. So based on the assumption, our portfolio beta should be the weighted average of the individual stock beta. And here the weight should be equivalent to the percentage of our portfolio value invested in a particular stock. So here we invest 50% of our portfolio value in Goodman. So 0.5 times Goodman beta plus again 0.5 times Landry beta. So in this case, our portfolio beta is how much? 0.49. All right. Now, let us calculate portfolio beta for another portfolio. In this case, we have 4 stocks in this portfolio. Goodman, stock A, stock B, stock C. And we know the percentage of our portfolio invested in each of these 4 stocks. And we know the beta of stock A, B, and C. And we already calculated beta for Goodman. So let us copy the beta of Goodman here. And the beta of Goodman here is 1.54. Okay, now portfolio beta. So here we are going to use the formula sum product. So here our portfolio beta is the weighted average of the individual beta. So we are going to choose our beta, and then we are going to apply portfolio weight over the individual beta to get the portfolio beta. So here our portfolio beta is how much? 1.18. Now let us calculate required return on this particular portfolio. So here our risk-free rate is 6.04%. Market risk premium is 5%. Then beta is 1.178. So now let us calculate our portfolio beta. risk-free rate plus market risk premium times beta. So our portfolio required rate of return is 11.93%. All right. Now, let us calculate required rate of return using Fama-French three-factor model. Here, we know the risk-free rate here, 0%, and then coefficient for market return, SMB, HML. So now, we are going to calculate our expected rate of return using the, or required rate of return using the Fama-French three-factor model. It's equal risk-free rate, then plus RM times beta coefficient plus SMB times beta coefficient for SMB plus HML times beta coefficient for HML, and then our required rate of return in this case is how much? 16.96%. All right. Now we are gonna solve the very last problem here. So here we have some discrete probability distribution, and then in this case we have 5 different scenarios. We know the probability for each of those scenarios, and then we know the rate of return we can generate in each of these scenarios. Now we are going to calculate expected return. So here expected return is the weighted average return of the individual scenarios. So again, we are going to use sum product function. Then we are going to choose all the returns in all the scenarios. Then we are going to apply probability of each of these scenarios as the weight to get the weighted average return of the individual scenarios. So in this case, our expected return is 11.40%. Next, we're going to calculate our variance. So in this case, the formula for variance is what? Sum product of probability times squared value of the difference between individual return and expected return. So in other words, we can break it down into probability times the difference between individual return and expected return, again times the difference between individual return and expected return. So here we are going to again apply the sum product function. Let us apply sum product probability, the very first factor, then individual returns minus the expected return, then again individual returns minus expected return. So this is the variance. Now let us calculate sigma or standard deviation. So standard deviation is the square root of the variance. So the square root function here is SQRT of variance. So here our standard deviation is how much? 26.69%. All right, that's all from the chapter. Thank you.